This is the field of water under low temperature, kind of a perfect analogy. Magnetism is a dielectric field. These two conjugate geometries, of course, are the hyperboloid, or the hourglass shape, respectively, and the toroid of magnetism. People love to talk about vortexes, though. I love to talk about the vortex mathematics. People love to. It's like people talk about the golden ratio. I say, well, do you know what a vortex is? Well, yeah, it's like a funnel. Everybody loves a vortex, and everybody does love a vortex. But instead of descriptions and the fact that they're beautiful and fascinating, what about explaining what a vortex is so simply that even a child could understand it? Because we all pulled the drain on the bathtub or the sink and watched the little vortex form. Yeah, of course, it goes down the drain. Vortex is just a half a torus. A torus, of course, would be like a donut shape. Well, we only recognize the one end of the vortex because the vortex terminates, since we're talking about centripetal convergence, but the end of the vortex also, too, is centrifugal divergence. But people usually don't recognize, like in the case of cyclonic or hurricane activity, upper atmospheric convergence, lower atmospheric divergence. We recognize the eye of the hurricane, like the center of a tornado, which I've not been in, but it's incredibly small. So that vortex actually comes down. We're looking at simplex pressure mediation. What would the eye of the hurricane be? The center of the plane of inertia is just the null point. The center of the hurricane is the center of the plane of inertia. Everything in nature, including spiral arm galaxies and everything else, we have, it's kind of not drawn perfectly here, we have this plane of inertia where basically everything exists, like in the case of a spiral arm galaxy. And right at the center, there's that hole. Yeah? You've seen this, too, on the countless thousands of ferrocellite supercell videos that I've made. There's a big black hole on the center of either magnet, and underneath the magnetic viewing film, you can actually see the plane of inertia. You take a big magnet, you put it behind this, you'll see a white line right at the center. Of course, not that you could slice neodymium iron boron or ferrite because they're ceramic and brittle, but if you could slice them like salami, each new half would have a new plane of inertia because there's nothing located there. And this gets into having the near-perfect analogy for incommensurability. The Greeks had three words for this that are basically untranslatable: euristos dias, tolma, and ananke. Interestingly about that hole, just like the center of a hurricane where we actually have perfect peace, yeah? Center of a magnet, that plane of inertia. What about the dead center of the center of a magnet? We see the same thing whether a magnet is solid or not because the field geometry is unchanged. I have one right over there, but a donut-shaped or a ring magnet. You put it underneath the ferrocell, yeah? You see the exact same field geometry of the torus and the hyperboloid and a little black spot right at the center. The reason is that respective of the shape of the magnet, this is so important, no one's ever talked about this in any YouTube video or any article either, respective of the shape of that magnet, the field geometry between the conjugate geometry of the magnetic and the dielectric, respectively the torus and the hyperboloid, which by the way also too are the inverse image of one another. Negative image of a hyperboloid is a torus. Negative image of a torus is a hyperboloid. Remains the same. Now, superficially, if I were to take a ring magnet, I'm sorry I don't have one right here, they're right over there, and say, I'm going to put this block magnet underneath the ferrocell. And someone say, yeah, I've seen the ferrocell image before. Yeah. What about this ring magnet, the center of which, where there's nothing there, except the field, of course? Am I going to see something different? Well, sure you are, because this magnet is a circle. There's nothing in the middle of it, just air. You could stick your finger in it and wear it like a ring. This would be called a ring magnet. No, it's exactly identical, because the magnetic field remains unchanged. Respectively, once again, the torus and the hyperboloid. Everything from physics and metaphysics follows this simplicity. Now, the crosshatch pattern in the center, as you can see, is the hourglass shape. Superimposed on top of that is, of course, the torus. The plane of inertia, which fascinates people so much, of course, would be right here. In explaining the plane of inertia, people love, just like they like talking about vortexes and the golden ratio, they love talking about plane of inertia. A lot of people talk about it. Well, let's try to explain it, because now we have the plane of inertia right here. Well, what is the plane of inertia? Plane of inertia is the rest geometry between the conjugate respective fields of magnetism and dielectricity, because everything in Mother Nature is not governed by math or even arithmetic, but by pressure mediation. The lowest null point for something to exist between, I say, the fighting fields, because magnetism is a dielectric field. Magnetic field, of course, is toroidal, and the dielectric field is hyperboloid. Well, what's the lowest null pressure point? And the lowest null pressure point between like fighting waters, where water is churning up and it's like fighting the incoming water versus the outgoing water. In cases we have these little eddy currents where actually little things, spin up and they're actually at rest between the fighting. Well, that's the rest point between the two competing fields that are interlacing each other between constructive and destructive interference. This place, which is where most life lives, same as our spiral arm galaxy, this little place right here. Why is it there? Between the centrifugal divergence of the torus and the centripetal convergence of the hyperboloid, yeah, We have two competing fields, interlacing, constructive and destructive interference. The lowest null pressure point, or rest point, is right here at the plane of inertia. That's all the plane of inertia is. It's the rest geometry between the conjugate fields. And right here at the dead center, where it is absolute rest, yeah, I'm going to actually erase the chalk there. Yeah, right here. Kind of like your belly button, kind of like the womb. Because the head is a cavity too. And we got a brain in the cavity of our heads, it's still a cavity.